Okay, let's take a look at this design methodology. I pulled in this design that is offered for free by a company called Eclipsing. And what they've done is they've figured out a way to model um, wings and other structures so that they can be printed in vase mode and introduce internal components like these ribs. That may not seem like a lot, but it is if you take a look at the result. So this is a solid model. This has a spar hole penetrating it. This has a channel for wiring for the servos right here. Excuse me. But it also has these ribs designed in. Here, they look like they're solid. But in essence, this entire part is solid except for the ribs. So if you take a closer look, sorry, I'm having trouble with the mouse here. You take a closer look, let's go in here and look at this rib. This rib is actually a slot in the part. What happens in vase mode, everything is printed as a perimeter. But you've got these interior components, like ribs, that are not perimeter, they're interior. So by putting a small gap here and putting a little slice into the part, you create a wall. And in fact, on closer inspection, you'll see that you're creating a wall and then another wall at the top that does not penetrate the top surface of the part. So if you look at the top of the part, before I go there, what it does is it creates a place for the printer to come along a wall, cross over, and come back down a wall in very close proximity to the prior wall, which allows the plastic to bond because it's in close proximity. So it's as if there's no gap there because the gap is so small. So looking at this end of it, notice by rotating you can see that that does not exit the upper surface. So as a result, by its close proximity to itself, you get a bond across that gap. And if you want to tie it in, this one is not, but if you want to tie it in with an adjacent structure, you can put it in close proximity to this opening right here and have this wall tied to that wall. Okay, so based on that discovery, what I did is I went in and took the NIAR drone full scale and I broke it up into pieces that can be printed on my printer. If there's a larger printer, it wouldn't have to be broken up as much, but by breaking it up, I was able to do the same thing, introduce these slots. So first of all, I had this spar hole. I added that. I added this hole for the servo wires to go through. I already had the OML of the aircraft. Since this is a flying wing, it's, practically all wing. So I had that wall, or that surface, and I designed in For example, to help hold this spar hole in place, I was able to design in this slot. So as you come along, as the printer comes along this edge, then it travels up this edge, goes around this perimeter of the hole, further up. It does not penetrate the top surface. Okay, so I have an offset to that surface that I use to split off a rib. That's something else I did. I came up with a pretty fast way to create these ribs. This is more like a spar, but then it comes back down this wall, around this perimeter, down the perimeter, and continues on its merry way to continue creating the outer surface of the part. Okay, so I did the same thing. It took some experimenting because I was running into errors when I sliced it. And the errors were all mine, of course, but it's me trying to understand how they got these ribs in as well. So let's go to a pocket, this pocket. So at this stage of the design, for some reason we're not rotating. I have to reset my 3D Connection mouse. So by putting that pocket in, I stopped it short of the spar hole, and I stopped it barely short of the wiring hole. So we should get a bond across here. This slot here should bond with the adjacent slot. And if you don't know what vase mode is, picture printing this bottom edge and doing a spiral all the way to the top without ever crossing over any other path. So it's a continuous spiral. That's what's really cool about this design method. So here I put in another part of the rib, and then filled this gap right here between the two ribs. So now if I wanted to, I could make that gap really small and I could bond with this spar hole, which I think I'll do later. But you get the idea, hopefully. It'll be a little more clear if I go and slice this resulting part. So let me pull up my folder where I have this part saved. So after I was all done designing it, I was exporting to STL. So let's pull up the STL. So I went through 39 iterations on this part, 39 exports until I got something that I think is going to print well. And I'm printing it right now, so we'll see. So by opening this, by the way, I ran this through my slicer so that I could understand it also, but I'm going to try and document this design method. Now this is full scale, so it will not fit on my printer. My intention is to make it 1/3 scale so that it can be printed and also the NIAR MIC Manufacturing Innovation Center would like to use a 3D printable version of the drone to do the printing on site and then the robotic assembly using the MIC. So I'm going to get this all designed, at least so it can be assembled. It may not be structurally sound, but that can be a further extension of what I'm doing here. So I'm choosing my material. I'm not going to be real picky about that right now because I'm wanting to show just what the result is with a vase mode. Now this tells you that it's going to disable this upper surface and make some other changes, which is what vase mode does. So now I can slice this part. And instead of slicing it in layers, it slices it in a spiral. And it's only going to take 2 hours and 17 minutes to print. I played around with printing this not in vase mode, and it's 30 to 200% slower depending on how much infill I use. But here you can see the result. It does show that it is going to create the ribs that are internal. It's going to create the spar hole. So everything is there. So turning it this way, you can see there are penetrations on this side, but they're narrow. And because they're narrow, which, I'd scaled up 3 times because I knew I was going to print this 1/3 scale. Because they are narrow, they're going to bond with each other. Now, I do have this printing right now. Let me slide this down so you can see. It's just one continuous spiral all the way up. Some of this is not being printed because it's zero-sum thickness, which is because it's a OML surface, which I'm going to look at why that is cutting off. But still, we get the result we're after here. Okay, in CATIA, after studying that, creating the root, then here's the next 1/3 of the model. So this I called the trunk. This is the next section of the wing. I'm going to go ahead and model in the ribs there. I've got the datum planes shown already. So I'm going to work on that and do a quick and dirty addition of ribs. Let's minimize this. Don't need that anymore. I've already sliced it on my home computer and I have it running right now. So you can see it running. Let's turn on the flashlight. So right now it's printing the bottom layer. And then once it's done establishing that thickness at the bottom, it will start doing the spiral. So, assuming that all goes well, I'll document that design method and see if I can see from this camera right here. You can see a little better. Excuse me while that camera comes up. So here you can see it printing. It's printing that base layer. And then, like I said, it will start the spiral. I'm not using lightweight PLA. I'm just using some PLA that I have already loaded to print these Mahjong boards. But that's pretty cool the way that Eclipson models their structures. So again, there's the Eclipson model. You can see I followed that spar method, except I didn't chamfer the end, but that's a detail that I haven't done. It looks like they might have, no, they didn't. I was going to say it looked like they might have supported that tube with the rib, and they didn't. I'm going to try that, make it tighter later. So there you have it. When I get that print done, I'll carry it into the office so we have something to look at anytime you're in town. All right. Thank you for your time.